So let's hear some of these similarities and differences you have for internal and external energy. Do we want to start with similarities or differences? But Alex, give me a major difference, please. And external energy comes from the sun. Perfect. Make sure you have that in the external side. Don't accidentally just switch your sides. How about internal energy? Where's that one from? Okay, so comes from, there are two places. One is radioactive decay. Radioactive is one word, despite how I wrote it. And where's the other place it comes from? Okay, yep. Left over from formation of Earth. Hey, Alex, you're on a roll. What's a similarity? You do too. That would work. You said something even simpler earlier today. Okay, yeah, they are energy. I don't really have many other similarities. Does anybody else have a similarity? Yeah. Okay, they both energy, which heat is energy. Heat is energy, yes. Anybody else? Is external energy on Earth? It's what? I don't know. I don't want to put that because literally external energy is energy not from Earth. I mean, I see what you're saying. It does heat up Earth. So I see where you're going, but I don't know how to put that in words and not confuse people. Anything else we should include? All right, let's leave it at that then. Excellent choices there. So then you guys ended up ahead of my other classes. So the only thing left is another situation where I got a reading and then some notes, but let's just do the notes. Is that better? All right, so these words should start sounding familiar here. We're going to be talking about the different types of energy transfer. In fact, it appears because I am skipping the reading part that we don't have a title here on this page. So let's title this page. So we are going to be talking about heat, which again is energy, transfers. What do I mean by transfer? Heat transfers. How heat moves from one place to another. There are three ways: radiation, conduction, and convection. I know this was either part of your 6th, 7th, or 8th grade science years. So hopefully some of this sounds familiar. Anybody got any of them? Like any of them ringing bells? Yeah, Nick. Which one? Convection. What do we know already about convection? Yep. So Nick just did the whole circle thing where what goes up? Hot air or hot anything, because remember, it's happening in the mantle. It happens in boiling water. Any of those. So when heat goes up and cold comes down, that is convection. And the other two sound familiar? Conduction or radiation. TJ, which one you got? Conduction. What do you got to do for conduction? You gotta touch. And who remembers anything about radiation, or don't we remember that one? Radioactive is radiation, absolutely. So that one, there's a little bit more to radiation, but you've got an example. That was perfect. So let's start right away with radiation. Here is the definition for radiation. This is when energy is transferred in the form of waves. I don't remember if I went over or down. I guess I went down. So we already did talk about conduction. This is transfer of energy when one hot molecule touches another hot molecule. This is when you have to touch something. And Nick told us the gist of convection, but hopefully that one sounds familiar because we learned it already this year. This one is when energy is transferred from one place to another when the heated molecules actually move. Is that better? Okay, now I'm gonna have you talk amongst yourselves for a couple of minutes here. Don't fill in anything just in case you have something wrong, but I want you to think of a phase of matter that they could go through, or which phases of matter. First of all, do you know what I mean when I'm talking about phase of matter? Solid, liquid, or gas. See it between the three, whoever you're talking with. So whether it's a group of 2 or 3 or 4, I don't really care. Tell me, do you think heat can transfer with radiation through solids, liquids, or gases? Same with conduction and convection. Think if you can give me an example, like walk me through an example of radiation, conduction, or convection. And then, of course, we can all confer on drawing pictures however you want. So talk amongst yourselves. I don't care who you talk to or how many people, but I want you to think of some phases of matter examples. See if you can do this one first without me just telling it to you. So go ahead, talk for a few minutes. We're thinking you got any phases of matter for radiation? Yeah. Everything. So radiation, these waves can travel through solids and transfer heat. Okay, so but the radiation is the one coming from the microwave itself. Yeah. So radiation is heating up the food, but it is traveling through the microwave in the form of waves. So it has to, radiation can only go through gases. Radiation can only travel through gas. Then something else is heating up the rest of the food. So gas is what for radiation. How about conduction? So remember, as TJ said, you got to touch this one. Not all 3. This one's going to be solid. Oops, and I just gave away the answer there. I did spoil it, but we did already learn that one. So hopefully you remember for convection, we know warm air rises. We should also know that warm water rises. And we already talked about how the warm mantle rises. So convection can be through all 3. I heard Nick already told us one good example of radiation is a microwave. Not gonna lie, the microwave is a little bit advanced for earth science. Mrs. Saley, when you go to physics, which some of you will take your senior year, has a whole unit on waves and microwaves and things like that. So that is, we're gonna get into microwaves later in your life if you continue on. Is there an easier to understand example of radiation? Yeah, the sun. Energy coming from the sun is one. How about another one? What's another thing that heat travels through the air and you don't have to touch it to feel it? Huh? Heat lamps? What'd you say? Hot pavement even. How about a fire? Like a campfire. Do you have to touch a campfire to feel its heat? Yeah. No, the energy is coming off of the campfire in the form of waves, radiation. Yeah. Yeah, a radiator is legit the answer to that one as well. So again, a radiator, if you don't know what, there's some in cars or old fashioned or houses that have boilers instead of forced air. The hot water goes through a radiator and then you can feel it without touching it. How about conduction? Sometime when you have to touch something to feel its heat. Give me one example. What, okay, so I don't understand welding, so I can't. Is that how it works? I don't know how welding works. I don't know. That's where I'm. Yeah, so if you touch the hot stuff, that would be conduction in welding. I would have to ask somebody who understands welding more than me to answer, to say if you're yes or right.
Have a sauce on the stove or on a hot plate, you know what I mean?
Yeah, I heard a bunch of you talking about this example. If you have a pot on the stove, there's a couple different ways. So you're just talking about the pot on the stove, the pot heats up.
Yes.
What's another like part of that you can, that would be an example of conduction with that pot on the stove? What? Okay, if you dip dipping your finger in the water, you're touching it. How, you ever leave, a spoon or something in that hot water? You have to grab that spoon? No, not a metal spoon, a wooden spoon, that could get hot too. But not that hot, but I've definitely, not really thought about it and left a spoon or a fork in there and grabbed whatever, and some of my utensils my like serving ones are metal, they get hot. Even if you just touch the handle, it gets hot. Let's talk about a fire. When with a fire is there conduction?
On the flame.
Okay, so if you actually touch the thing that's hot, if you're inside of the fire that's hot, you guys ever roast marshmallows? Yeah? You burned some marshmallows, that you said? Burn some marshmallow, okay. What do you use to roast your marshmallow? Stick. That stick ever get hot?
Yeah.
Yeah. And if you guys have like metal marshmallow roasters,
Yeah.
what kind of handle do they typically have? Either plastic or wooden or rubber. What if they did not have that rubber and you just tried to use a metal stick? It would get hot. Like, how does that metal get hot if the handle's not even in the fire? It's conduction. How that works is the end that is in the fire, clearly you can see that that's getting hot. Okay, that is getting hot. Then what happens is one molecule that was in the fire, you know how molecules move? So that molecule touches the molecule next to it. It warms up. It touches the guy next to it. And then it warms up. And it just keeps touching. One hot molecule touches the next hot molecule and warms it up all the way up to your hand. So I think that's actually the example I used. I said a hot fork in a fire. You can use the handle of a pan is another great example. The key is you have to touch. And that's how the molecules get warmed up too. One hot molecule touches another hot molecule, touches another one, and they just heat up all the way to the end. Convection, we have talked about convection a bunch. Give me some good examples. Taylor, give me an example of convection. An oven, what about it? You just know convection oven? Okay, give me an example that shows that heat moving. Yep. When you boil hot water, what do the bubbles do? They rise. The bubbles go from the bottom to the top, then they pop. That's a good example. TJ just said steam. What does steam do? It goes up. And then once it gets up, we probably can't see it come down, but once it gets up, once it cools, it comes down. Give me another example. Let's stick with our campfire example. Where is there convection in a campfire? Okay, so yes, if you boil water, what? The smoke, guys, where does smoke go? Up. If the wind blows it, then it goes up and in your face. But the key is the smoke has to rise. Why does the smoke rise? What is smoke? Is it hot or cold? Hot. Okay, that is hot air that's rising. It has some color to it so you can see it rising. Do you have an example, Ruby? No, no examples of convection at all? Okay, give me another one.
When you're at a campfire, like the embers go off.
Yeah.
come down.
Yes, and then they come down and burn you. So you guys have probably seen the sparks coming off of a campfire. Again, they typically go up. Come on, there's more examples. It doesn't have to be a campfire. Give me some more examples of convection in your real life. It doesn't have to be sciencey life.
You boil what?
What we said we boil water. What'd you say?
So, yeah,
Inside of what?
you're,
Inside of the earth. Okay, that's a good earth science example, because we know that the heat is coming up and then cooling down. That is what is causing the plate tectonics. Yeah, real life example. Again, we already covered boiling water, guys. Anybody have a bunk bed? How's that top bunk feel in the summer? Anytime. Warm. It is warmer at the ceiling than it is at the floor because warm air rises. I think I used the campfire example, but again, you can use, oh, nope, I use boiling water. So for the picture here for radiation, we could pick a bunch of different things. What picture should we draw, you guys? I don't know how to draw a microwave. And to be perfectly honest, I don't know all the physics of a microwave and exactly how it works. Let's stick with earth sciencey examples. How about, what's that? That's the sun. And how do we have to touch the sun to get hot? No, we do not. Heat travels in waves towards Earth and makes us happy. Whoa. That's supposed to be a smiley face. That looks horrible. How about conduction? What's a picture we can draw for conduction? Okay, let's try a fire. Here's my fire. Now, I'm not gonna make it as vicious as somebody in a fire. So I'm gonna take a person. And they're going to have that fork that I was talking about before. Yeah, it's a big marshmallow, like a hot dog fork. How about that? And they're saying, ow. And there's, ow, because it hurts, it's hot. Convection, what is something we should draw for convection? Yeah.
We could draw the earth with the circular arrows.
We could draw the earth with some circles and some arrows. That might work. I'm gonna go simpler. Because I'm not the greatest drawer. Here's my pan. Here's the fire. And I'm just going to show, just like you said, those circles where it's coming up and going down. Oh, my handle should be up higher. If you need a label that pan convection. So these are how energy is transferred through Earth and space and everything in between. So this is where we're going to stop for your class because my other classes did not finish the internal and external energy. You have homework though. So I want this class working on their homework now, which is pages 5 and 6. It is all with the reference table that we looked at yesterday and the reference table on the front page. So page 14, the atmosphere reference table, and page 1 that has the different, I guess, called ingredients of the crust, hydrosphere and atmosphere. On the back, question 15, it looks like letters blob and blob. I'm not sure what happened there, but it's A and B. Anybody want the light on to look at the reference table? Okay, you guys are Better than me. All right, so work on your homework.